Welcome everybody to Java 24, a story of code, conflict and conquer. My name is Lutske de Leeuw and today I'm going to talk about the newest Java 24 feature in Storytell mode. So, as per now, you're in a new team. Forget your old team. This is your new team. We got Emma. Emma is very curious, is our weekend warrior, and she loves to explore things. We got Ray, and Ray is just from school, very eager to learn, and wants to know everything. We've got Ben, our seasoned dev. He's been here a while, he likes things the old way, but he's not retired yet. And John, I don't know why he is in this team. He doesn't even like Java, he loves Rust, but he ended up on our team, so we have to deal with him. So, in a world far, far away from here, there was a Java application running smoothly, the servers were stable, logs were quiet, Emma and her team lived in peace. But at one moment, there was a spike in the memory usage. And another one, but it didn't change any code. So how could this happen? There was an invisible enemy, unnecessary inflated object headers. And this was the start of the memory wars. So, Emma and her team were puzzled. How could it happen? And why? So they dug into the heap and discovered this unnecessary inflated object headers. So, question, who knows what a JEP is? Please raise your hand. Oh, some of you don't. That's good, because I have this slide. A JEP stands for the JDK Enhancement Proposal. So simply said, it's the newest Java feature. And JDK stands for Java Development Kit. And who here, once again, works with quantum computing in production? Nobody? Ah, that's too bad. But just so you know, in the newest Java 24, we have two JEPs that have to do with quantum computing. They're both about module ledgers based, and they're JEP 496 and 7. And one is about the key encapsulation mechanism, and the other one about digital signature algorithm, and they're both to prevent future quantum computing attacks. And the 467, that has to do with detect unauthorized modifications and to authenticate identity signatories. And the other one is about the communication channels and public key cryptography, but none of you are working with quantum computing yet, so I won't tell about this anymore, but just now it's there. So, who here had ever debugged a memory issue? Yeah, okay, luckily. So, we can talk about some things. So, first I want to explain something about object headers. An object header is literally an object with a head, and it's always the overhead. When you create an object in Java, there's always some metadata stored, and that's what we called the object header. So how does this look like? There's a lot of them, but I'll try to explain to you. So first, we have the class for it, and in there's a compressed class pointer of 32 bits. And that's already compressed, just remember that. Then we have the mark word, and the mark word has multiple things in them. One of them is the tag, it's the label, it's in 2 bits. We have the 8, and it has all to do with garbage collecting, but for garbage collecting, there's a whole other talk for 50 minutes, so I won't explain that, I hope you know it, and otherwise, look up Garrett Grunwald's trash talk. We have the identity hash code, and the identity hash code, it's basically the identity, and it's 31 bits. And you probably also noticed we have some unused bits. That's quite interesting. So where are those unused bits used for? So back in the day, we had something called bias locking. And we used 1 bit of the object header to store if it was bias locked or not. But it was already disabled in JDK 17 and deleted in JDK 21, so it's legacy. The same is with the concurrent mark and sweep garbage collection. That was already disabled in JDK 9 and deleted in JDK 40, so that's very old. And something with overriding, the biggest chunk. Because here we have the mark word again, so the 64 bits. And there's something we call legacy stack locking. So if we lock the object, it overrides most of the mark word, like you see here, and it has a pointer to a more complex data structure. And instead of the tag, we have a label in it. But this was default till Java 22. And in Java 21, they introduced something called lightweight locking. So we don't need this anymore. And now, and in Java 23, they made it a default. So we don't use the first 25 bits anymore. That's interesting. So the silent war rages on in the system. The enemy is invisible. And the team is fighting with everything they got. They tweak the garbage collection, they analyze the heap dumps, but nothing is working. And the object headers keep growing and growing like an enemy army. The servers are getting overloaded, and the application is in danger of being defeated. So Emma stands for a choice. Does she keep fighting with everything she got now, or does she need to search for a new weapon? So she searches and searches, and the teams feel the pressure of the current deadline and the increasing performance issues. The tension is in the air. The enemy seems stronger than ever, and the chance to grab grip on the situation slims with every minute. But deep in the Java 24 release notes, she finds something. The weapon, JEP 455 compact object headers. And like the name already says it, it's more compact. And that way, you can store more objects in the cache. And the best of all, you don't need to change any code for it to use this. So how does this work? So previously, in the top, we had the 64 bits for the mark word and 32 for the class word. And now we have an object header of 64 bits. So the compressed class pointer is still there, but it's now 10 bytes shorter of a bit, because the first part of the compressed class pointer was always the same, so we could just delete that. The identity hash code has just stayed the same, so it's still 31 bits. We have the age, also the same, still 4 bits. The tag is 2 bits. They added an extra bit for the self-forwarding tag, because things have changed with the garbage collection, and now there's a higher chance when copying during the garbage collection phase, it fails. So this one is there to secure it's still forwarded to the correct object if everything fails. And you see the unused parts are gone. But they added some reserved parts. And they did this because Java is always evolving, so you need to think about future things that can change and you need space for. So, one of the things they have the reserved bits for is Project Valhalla. And Project Valhalla is all about making things better in Java. Sorry. It's since 2014, it's an OpenJDK initiative, and it's more about value classes. I will tell you about it later. More about generics and how can we optimize that in primitive classes. And we have Project Lilliput. And Project Lilliput is more about make the object headers more tiny. So now they were very big, as you saw, but with Project Lilliput, we want to make them even smaller to 4 bits. So that's very small. This is also an OpenJDK initiative, and it is really cool because why wouldn't we make it smaller, make it more efficient, better performance, and a lower footprint? So I think that's amazing. And this JEP 450 is also a child, but come from Project Lilliput. And now I have something you probably never heard before, never seen before, because this is the timeline for Project Lilliput. You don't have to read everything, I will talk you through it. But this was recently, like a month ago, discussed at the OpenJDK workshop. So, very cool, at least, I think. So, currently in Java 24, in Java 26, I don't participate in Project Lilliput, but they are gonna add compact full garbage collecting forwarding, and you see some numbers in them. They're the actual JIRA numbers of Project Lilliput, and I will add the use compact object headers on by default. In JDK 27, we'll make the use compact object headers obsolete and implement the compact identity hash code. So as you've seen before, the identity hash code didn't change, but now they want to make it smaller and also implement the 4 bytes header. In JDK 28, make the tiny object headers non-experimental. In 29, make it on by default and deprecate the flags. And in JDK 30, make the tiny object headers flag completely obsolete. So that's very cool. In JDK 30, it's going to be all in there. So, how can we use this weapon? It's very easy. You use this in your command line, so you're in Java with -XX, that stands for experimental, because you just saw in the timeline, it's not completely there. -jar with your jar name. So, the clock ticks, Emma runs her application with this newly activated weapon, and the memory uses slims. The object header shrinks, freeing up more space in the heap, and the system, which was just about to collapse, could finally breathe again. And because of this flag, the size of the object header is down with 33%. They did this on live projects and then reduced with 10 to up to 20%, so that's pretty much. And the garbage collection passes are very small. So, was this the only solution for Emma? No, she could also been going through another path. So let's see at an alternative timeline, the value classes. So I talked about you that Project Valhalla introduced value classes. And here I'm going to show you some examples. This is a point class, and we make it final, because the difference between normal Java classes and value classes are with normal classes, you point to somewhere. You can adjust the value, and that can be used in other parts of the program. With value-based classes, you only have the value, point. That's it, nothing more. So, because of the value classes are immutable, we make things final. So here we see the class point with 3 ints, x, y, and z, with a constructor with it to setting those values. And here we see we're creating a new point called origin with the value 0, 0, 0. We have the value of the point, that's a method that checked if it's the origin. And in the bottom you will see the is origin with x, y, and z, where it checks if it's equal to 0. If that's the case, it will return the original object and otherwise create a new point. We also override the equals method with it's not null, and if it's not a class, it's already not the same, and otherwise cast it to a point and check if the x, y, and z are the same. And we override the hash code, as you can see here. If we see this in test, we can create 2 points with the same values, 1, 2, and 3, and then we do an assert equals. If we do this, it will return true. And we have the bottom one, where we can do we also create 2 points with the value 0, 0, 0, and that till 2 times, and then we do an assert 2 with double equals. But if we do that, that's not always the case, the assumption. So that's very good to take in mind. So before we go further with the story, maybe I should introduce myself. My name is Lutske de Leeuw. I work for Craftsman. I'm almost 10 years in IT. I'm a full stack developer, or whatever label you can put on it. I mainly focus on Java, AI, and Angular. You can find me on the socials with my first name, because it's very unique, unless for Blue Sky somebody tokened it already. And I work for Craftsman. I'm also here as a JUG organizer, the Java user group. I'm here with the Apeldoorn JUG and the JUG Noord. We're also at the JUG Square at the 3rd floor, so please give us a visit and sign up for the next meetup and be there also. And one more commercial slide. It's already mentioned in the keynote, but DevX for Kids, that's an organization from the DevX family to make kids find programming more interesting. And Little, that's more about schools connecting them to programming professionals. So, if you would like it, I would like to make a picture with all of you. If you don't want to be on the socials, please hide your face on a chair next to your neighbor or whatever. And let's pretend we all just won 500,000 millions of euros. So, smile! And yay! No? Okay. Thank you. So, back to the story. And they lived happily ever after. And they lived happily ever after. Right? No, of course not. We have lots of time left. So, now let's explain some more JEP features. So, it was Friday afternoon, the team was packing up, everybody was discussing what they were going to eat, and John was at his laptop. And he was like, ugh, it takes forever to start. And Emma chuckled, it's not that bad, right? And John said, yes, it is. I went to make some coffee, and I went back, and it was still booting. And you know, I make slow coffee, so not this corporate garbage shit. This is not okay. But he rage quit, put out his laptop, and went home. But Emma couldn't shake the thought. Can we change the startup time? Can we make this smaller? So she couldn't let it go. And to explore more for the story, you need to know how class loading works. So normally in Java, class loading is very lazy. So it only loads classes one by one when they are needed. But that's just like a party where everybody at the front door, you have to check the passport if they really say who they are, and it takes a long time. So you don't want that. You just want the party to get started. And therefore, there's something called ahead-of-time class loading. And then all the classes at once, just like a big bundle, already at your party. And there's something for that, of course. The JEP 483, ahead-of-time class loading and linking. And to do this, we have 3 easy steps. We have to record the application, we have to create an ahead-of-time bundle, and we run it with the ahead-of-time bundle. So another question, who here knows the Dutch city Leiden? Almost everybody, okay. Did you know that there's a project called Leyden with the Y in it? I don't know, it's epsilon? No, I don't know it in English. And this is a very recent OpenJDK initiative that's here since May 2022. And that's all about performance optimization. So faster startup times, more compatibility. And the coolest thing is, this was started in the Dutch city Leiden. So depending on your thing of distance, but close by Amsterdam. And out of project Leiden, this JEP came. So how do we do that? Emma started her hobby project, did a Maven clean package, and then she started her application. And it started in 2.09 seconds. Not too bad for a hobby project. Then, to capture it, we again, using the experimental XX, we use the ahead-of-time mode record, we use a configuration, and we're calling the jar we're using. Then we can record it and use the application. And we're clicking something in the application, not doing it here now. I'm afraid of the demo gods today. But once we've done that, we can create the bundle. So with the mode create, the same configuration, and a cache and a jar. And after that, we can start the application with the same cache, the jar, and a class. And now it started in 1.09 seconds. So Emma was very happy. She jumped up from her chair that even her cat, who was sleeping beside her, sturdily awaked because of her victorious cheer. So in Emma's example, we had a startup time of 50% more, almost twice as much. They also did this with the Spring Boot Pet Clinic application. That's a default example application. And there the startup time was reduced with 40%. So this is very interesting to do. And again, you don't need any code changes to do this. So, is this the end of the startup saga? No, of course not. We got more. So let's talk about concurrency. One morning, it was Monday morning, the stand-up was started, and John said, what if we write the process critical parts in REST? And everybody was like, what? Why? Why would you do that? But it was a stand-up, so there wasn't any time to discuss that further. But Emma thought, REST, I know it's very good in handling threads and stuff, but millions of threads manually, and if we now change to REST, then we need to do a steep learning curve, and we Ray just got to learn Java, and now this is too much. Let's not do this. But isn't there a way in Java to make this better? And while she's thinking about it, her cat was tangled in lots of threads of yarn from her knitting project, and she carefully freed him from all the yarn and was chuckling. Okay, let's find something in a Java ecosystem that's less of a headache for both of us. So what's the problem with threads and blocking threads? When you have more traffic, it's just with a highway. You can add some more lanes, some more threads, but you can't scale forever. There's a limit to it. And it's very expensive to make more threads. So you want something for that. And there is our superhero, JEP 491. And JEP 491 is all about synchronizing virtual threads without pinning. And our superhero is very lightweight, scalable, and effective. And to see how this works, let's talk about virtual threads. So in the normal case, we have on the left, you have the operating system kernel who have some threads, and on top of them is the JVM, and the JVM has platform threads. So every thread has a platform thread for it. Since Java 21, we have something called Java virtual threads. So now, when a platform thread is blocked, we have a next virtual thread on top. So you have a pool of virtual threads they can change between. It's just like passengers on a train with limited seating, they just take turns on who can sit. But you probably wonder, yeah, but that was already here since Java 21. And that's correct. So what's the difference with Java 24? So now it's without pinning. So previously, when you had code looking like this, so we had a synchronized block with something reading or something. Here it could be blocked, and then it would pin, and that would say it would block the whole thread, not only the virtual thread, but the whole process. Like, I'm here and I'm waiting, get out of the way. You don't want that. So now you can unpin it, unmount it, by doing something called wait or something. And then you can unmount the thread, it will go on, and when it's done, it comes back, and it will just continue with this. So this is a very easy way to change the virtual threads and make the virtual threads more useful. And Emma and her team, they had far more requests, 10 times more requests, and 0 meltdowns of John. And believe me, John had a lot of meltdowns before. So this was better for the team. So let's go on to the next JEP, the great JEP 485. Because of all the recent successes of the team, they invented JEP Friday. And in JEP Friday, the afternoon, they would take a new JEP from the Java and see how can they use that to their own project to optimize it and make it better, or not, depending on how they've been using it. So Emma and Ray were very enthusiastic. Yes, let's do this. How we can make this better? Ben was like, oh no, why? Why do we need to improve everything? And John was also like, yeah, we can do this, okay. And then Ray suggested something. What if we do a victory dance if we improve the application today? Emma was like, yes, let's do this. So, who here, raising hands again, knows the Java streams? Almost everyone, luckily. For the ones who didn't know or just forgetting, the stream pipelines is here since Java 8, so a little bit of time. And it's all about we're having some data, we're doing something with it, collecting it, all in one block. And if we do this, for this example, the outcome of this is 5. And it would be even better if you could do something like this. We could do more operations in between. But this is currently not possible. But JEP 485 is here, the stream gatherers. This is not new, it was already introduced in Java 22 and with the JEP 461. In Java 23, it was re-previewed with the JEP on the screen, and now in Java 24, it's finally finalized. So that's very nice. So there are some built-in gatherers. They could have built millions of them, but they didn't because otherwise it's too big of a change. So they added 5 defaults. One is the map concurrent, and that is one-on-one mapping, but with a limit, so you know how many you have in front of them. With scan, you also do one-to-one, but then you can do it on a stream, so it can go endlessly on. We have a window fixed, and as the name already suggested, you just say, I want this window, and that one, and go on. But here it's also limited. You have to say in front how big it is. With the window sliding, it just slides along, so it's again for the stream. And we have the fold, and that is many to one, and it's also for streaming, so it can also go and go on. So that's more about folding. And the next slide, you don't have to read everything, but just for the idea. This is without stream gatherers, and this is with. So I think that it's way more readable now. It's very more shorter, far more shorter. And back to the anatomy of the Java streams. So we also always have a source, an input, some intermediates, and then a terminal. Just remember this. And we can make some custom gatherers. So here we say we have a gatherer with some string inputs, and we will check if it's not null, and otherwise do an uppercase. You can build all kinds of stuff, of course, but just for a simple example. So if we here say the stream of ABC in lowercase, call this gatherer and do it to a list again, then it will translate to uppercase. And for the next slide, I would ask you to take your phone, scan the next QR code, and turn up the volume. So Emma and Ray, they decided this is working, so we really like it. So we wanted to do a victory dance. I heard some of you already scanned. I will wait for someone here in the front. Sorry, I did a rickroll. I couldn't let it out. I had to make some kind of jokes. So, is this all fiction? It depends. Of course, Emma and her team aren't real, so they don't exist, too bad, so you have to go back to your old team, happily or not, I don't know. Probably are some sponsors here who's searching for great developers if you hate your current team. But all the jobs are real, and other examples are really optimizing things. There are a lot of more of the jobs, and Emma and her team aren't there. Sad. So, like I said, there's online on the schedule you can vote the session, but that's only I like it or hate it or in between. If you could scan the left QR code, you can give feedback on the session. I really would like to improve myself. So if you can do that, that would be great. In the middle, you see a QR code with all the material I mentioned. So the jobs, the performance testing, the projects and stuff. Here you can find me on LinkedIn, and on the bottom, all the socials I'm at. I will be here all day, but I'm also volunteering, so I don't know how many questions. And please visit the Jug Square and the Sponsor Square and look up all the sponsors and stuff. I talk very fast. Sorry for that. So we got an early break. Thank you very much. My name is Lutske de Leeuw, and thank you for listening.